Don't act like you forgot. I called a shot.
Hello guys, welcome back to #tugasku. And now it's been a while to me to upload new video because like every time I'm upload like the material of Indonesia LWOOF. So now why I'm use English, because this is time to English. So this is mathematic, economics, English version, internationalization. So I'm gonna bring up the matrix inversion. So let's start it. So there's cofactor. Here's the first two and the last two calculation of matrix of minor. So this is, you can see that. So to find the second element of the minor, we can do it by crossing or elementing the first row and the first column. So you'll see that like there's the lines of the number for the rows and the columns, that the first row and the columns, then you can get it, the matrix, and then you calculate by the formula AB minus BC. Yeah, so you can get minus 24. So the next is cofactor 2. Then third is the matrix checkerboard. You can see plus minus plus minus plus minus plus minus. Yeah. So after obtaining the minor value to each matrix element, we can determine the value of the cofactor. And to find the cofactor, we should multiply the value to each element to positive or negative sign to the checkerboard. So checkerboard matrix checkerboard is easier to multiply for the cofactor for the matrix. So example, you can see the first you still matrix the minors, and then you use the checkerboard, and then you can get matrix of cofactor. So yes, you can see that. So the next is determinant of matrix is the special number that can be calculated from a square matrix. So here is 2x2 matrix. A equals AD means BC. The same for the first, like the determinant of A equals E times B minus B times C. So the example for you easy to understand. Yes, that's B minus that's number 4, 6, 3, 8, and then you determinant, and the result you get 14. So next for determinant is 3x2 matrix. So this like double number, and then you can, the formula is the determinant of A equals 86. That's little bit complicated. And for the 2x2 matrix formula, so that's a little bit complicated. So that's the example C, and then number 2, number 2, and then the middle is minus 2, and then the determinant for that you can clearly see the result is minus. So next is identity matrix. If the given square to any order which contain in the main diagonal elements with a value of 1, which the rest of the matrix elements are equal to 0. The order of the identity matrix is always n, and which refers to dimension nxn. So the meaning, the always same almost of rows account the matrix. So for the example, yes, there's simple number, there's 1, 0. So the next is inverse matrix. It's the same with reciprocal of number, but we write it. So there's like 2x2 matrix, but the inverse that you can see there, like in the top, you see the minus 1. So that's inverse matrix. You see minus 1, factor of minus 1, you see inverse matrix, and what is the position of A and B. put the negatives in front of B and C, and divide everything by the determinant. So the example you can see that. So non-singular metric is a square one whose determinant is not zero, are sometimes also called regular metrics. So there are 6 non-singular 2x2 matrix. So if the matrix is non-singular, then in the inverse exists. So example, there's the determinant O. Very clearly, you get the result is non-singular. X not equals 0. So non-singular. Singular matrix are those cannot be calculated if the determinant of matrix is 0. So you see that. So there's the example. You can pause because I'm worse of plan 2. So the last is square matrix. If the square matrix have n rows or columns, then the matrix is called the square matrix of order n or an n square matrix. So the definition of the square matrix is nxn or n multiple n matrix is said to be square matrix of order n. In other words, when the number of rows and the number of columns in the matrix are equal, then the matrix is called square matrix. So there's the example. So the number of rows of the above matrix is equals 3. The number of columns of the above matrix is equals 3 too. So since the number of rows and the number of columns are equal, the above matrix A is a square matrix. Yeah, so that's the matrix inversion. And again, sorry, it's like random, like okay, see you guys.